So this is a video for probability. And before we get started, make sure you have read the first two questions. It's okay if you don't understand them, but just kind of have a basic idea of them because I don't want to spend half this video just reading paragraphs that you could read, but I will summarize them. And then that's the first thing we're going to talk about. So if you haven't already, go ahead and look at those first two questions and then come back when you're ready. So here we have 3.1 Introduction to Probability, and we're going to start off by talking about statistical significance. So it says if the difference, I'm trying to move my face. I'm not sure if you can see me when I move the box. It was just on top of the words. Anyways, if the distance between the results and the expectation of an experiment is unlikely to be due to chance, the difference is statistically significant. So basically something that we want to talk about what's due to chance. Well, just think about flipping a coin. Could you flip a coin one time and get heads? Absolutely. Could you flip a coin 5 times in a row and get heads? Yeah. Could you flip it 10 times in a row and get heads? I mean, you could, right? Like, but the bigger this number I'm talking about, the more likely something a little fishy is going on, right? Like it's not a chance that this is going to happen. So like if I flipped a coin 100 times in a row and got heads every time, then we're saying, that's unlikely to be due to chance. Something fishy is going on. All right, so it's kind of a complicated topic, but we are not getting that deep right now. We're just staying at surface level because this whole unit 1 is about introduction to all the topics. We will dive deeper into this later in the course. So if you are finding yourself getting super deep into this topic and trying to like uncover what all these words mean and everything, you're too deep. We just want to stay at surface level right now. And so the two things we're going to go off of, if the probability of an observed result occurring by chance is 0.05 or less, then we say the difference is statistically significant at the 0.05 level. If the probability of an observed result occurring by chance is 0.01 or less, then the difference is statistically significant at the 0.01 level. And so it's really important to get like the or less part of this. So we have, I'm just trying to highlight this real quick. We have this 0.05 or less, and then the 0.01 or less. So you're not necessarily going to see those two numbers in every problem. You're not going to see 0.05 or 0.01, and that's it. But you will see numbers that you have to kind of figure out which category they fit into. So you'll see that on this first example, what I'm talking about. All right, so let's go ahead and go down and look at the first example. My pen was messing up, so I'm using Zoom stuff today just so I could get this video posted, and it's driving me crazy. Okay, so the first one, again, hopefully you've already read through this, but it's talking about a survey to determine if the political party has an impact on whether a person believes that higher education is necessary for career advancement. Okay, so it tells you who was surveyed, how much, and it talks about the Republicans, and it talks about the Democrats and all their results and yada, yada, yada. And then what we see here is it says that the calculations were, I'm gonna mess up this phrase the whole time, statistically significant at the 0.01 level of significance. So what is the correct interpretation of the data? And so what we're going to say to interpret, and we're just going to, when I interpret things, I pretty much just try to copy like as many words out of the paragraph as possible, just to kind of keep it all lined up. So we start off with the level at the 0.01 level of significance. And then what are they looking at? What are we deciding? We wanted to know if a person believes that higher education is necessary for career advancement. So we just say that higher education is or was necessary for career advancement. So we're just copying those letters like right out of the sentence or right out of the question. Higher education is necessary for career advancement. We're not concluding that higher education is necessary. We need the first part of the sentence there. We're just saying that it's at the 0.01 level of significance. So we're just saying how much of this conclusion is based off of chance. We are not saying we agree with the conclusion. We're not saying that this is true. None of that. We're just kind of saying what were they asking and what is the level of significance. So you're not really going to be writing a lot of these yourself. You're going to be looking at multiple choice and coming up with which is the best one that fits. But what I want to point out is we're looking for that level of significance. So we started off with the 0.01 because that was what was indicated in the problem. And remember, there's only two choices, 0.01 or 0.05. And then we state the conclusion. So then when you're reading through the choices, you're going to look for that level of significance, and then you're going to state the conclusion. Okay, so let's try this again on number 2. Oopsies, wrong button. I'm getting kind of fast at Zoom controls, but still not the fastest. Okay, so here we have again a situation, a poll talking about people in different countries determining how favorable the president is. And we're talking about people that are in this case, they're determining who's in favor of the president. So that's what our conclusion is going to be about. And then the other thing is the level of significance. So it says being a result of chance is 0.03. Now that wasn't a choice. The choices were, let me see if I can write this down, 0.05 or less, or 0.01 or less. And so this one has to be this top choice because it says, it's like, think of it like money, like a nickel or less, 5 cents or less. Yes, our little 3 cents in the problem would absolutely fall into that category. Okay, I deleted it accidentally. But the other one, 0.01 or less, that's a penny or less. That the number given in the problem is not less than a penny. So this one has to start at the 0.05 level of significance. And then we say what they're in favor of the president, something like that. It doesn't have to be perfectly worded. Again, you're going to be doing multiple choice for this type of problem, both on the test and on the homework. I just want you to be focusing on that level of significance. 1, that which number is it? And 2, don't make conclusions that we haven't talked about. So these are like the only types of conclusions we're talking about. So sometimes what I see on this is people will say like, well, the test wasn't fair, or the test was unbalanced, or it's not likely. Like, I didn't say any of those words, right? I said at the 0.05 level of significance, conclusion. So I just want you to see the pattern and see that it's showing up over and over again. What level of significance, and then conclusion. And that's it. And you're going to get it right every time if that's what you follow. Okay, let's be done with that and go on to some perhaps more familiar topics. Okay, so everything else we're going to talk about in this video, we have either talked about in this class already, or I know you have seen somewhere in before. So the rest of this video, the first few minutes is really the hardest part of this video. Okay, so what we're going to do here is we are going to convert a frequency distribution into a probability distribution. Easy peasy. That means a frequency table, which we've already done, into a relative frequency table, which we've already done. Probability distribution is the same thing as relative frequency. The only difference is relative frequency had a few different ways of writing it. You could write the decimal, you could write the percent, you could write the fraction. Probability is nearly always going to be a fraction. Like the only time we use a decimal is when there's round, like the numbers are really small, or there's rounding, or we don't want to worry about reducing and stuff like that. Okay, so this is how you do it. You count the total number, we get the sum of the frequencies, and then you divide each frequency by this sum. Exactly what we were doing in a previous video in chapter 2. Okay, I think I need to zoom out. Okay, there we go. Zoom out to get this whole thing on the screen. But here we have a student is opening, what is this? Probably M&Ms. I guess it could be Skittles with those colors. I don't know, whatever. Some kind of candy. I like M&Ms better, so I'm going to pretend they're M&Ms. Oh, purple. Purple's got to be Skittles, and I hate purple Skittles. So anyways, I'm going to pretend there's purple M&Ms. And they counted how often each color occurs. So the frequency is already written in this table. Construct a probability distribution for this frequency distribution. All right, pull out your calculator, add up the frequency column. So we have the 12, 13. This is not necessary to use any of the list functions in your calculator because we're not getting that fancy. We're just adding the numbers. So if I add all the numbers in here, I got 50. So there's 50 candies in here. Huh. I just put that on top of my PDF control. I don't know if you can see that. That's weird. Okay. Oh gosh, that got done. Okay, whatever. There's 50. I'll put it over here so we can see it better. Okay, there's 50 candies. All right, so that means each one here we want to write as a reduced fraction. Now, this is going to be 12 over 50. Bear with me as I figure out how to write a fraction on here. 12 over 50. Now, I want to show you something cool. I'm probably going to mess up this whole answer because I'm going to make myself big. You have it written down, 12 over 50. Okay. I think I'm going to delete everything. I don't care. I just want to show my face. Okay. There's a really cool button on your calculator. I'm trying to see if I have a light that will light up my calculator enough. I know I flip-flop between the types of videos that I use because it's hard to tell what you can see and what you can't see. Oh, not terrible. I don't know. I'm like literally blinded by all the lights in my eyes at the moment. So I'm not sure if you can see that. Anyways, there's this really cool button. Where's my camera? Right there. It says N over D. It's 2 over second column, third row, N over D. If you have a different calculator, oh my gosh, my thing's like pulsing at me. I got this like ring light at, where did I get it? Big Lots for $4. And it's like, can you see? Oh, you can't see, it's pulsing. It's like pretending I'm at like a discotheque or something. All right, just want to show you my calculator. Anyways, N over D button. Some people, graphing calculators, you have this button as well. N numerator, D denominator. And so if I type in 12, so I'm going to type in, I hate this. I hate this. Okay, I'm going to make another video on this. I'll just focus on this. 12, I'm just going to talk it through. Okay, that's what we're going to do. I'm going to talk it through, and then I'm going to make a different video where you can see my calculator better because this is just all kinds of not happening right now. All right, whatever. Okay, N over D. I'm a little excited about all my lights. I hit 12, and then I hit N over D. I know you can't see this. And then I hit 50. So number, fraction button, N over D, 50. And you'll see on your calculator that you have a fraction. Okay, it literally says 12 over 50. Hit enter, and it reduces the fraction for you, and it leaves it as a fraction, and that's my favorite thing. That's like one of my favorite things about these calculators is you could just reduce a fraction so easily. And so again, you type the fraction in and you hit enter and voila, it happens. Can other calculators do this? Graphing calculators, absolutely. Send me an email if you don't know how to do that. It's just like a little function. My kid took my calculator. It's up here, the F1. You can get your N over D from there. Other calculators, this is why I say to get this one because it has it. You might try Googling. I don't know, not a lot of calculators do that cool thing. So anyways, I will make another video about that. Let's move on to this again. Okay, so we have 6 over 25. That is our answer that we are going to go with. I'm just going to write my fractions sideways because it's going to take me forever if I do it the other way. Okay, probability of X. I hate that. It totally looks like June 25th to me, but we are just going to deal with it because my pen's not working. All right, 13 over 50. I reduced it on my calculator. It is what it is. You might have already known that 13 over 50 didn't reduce because 13 is not even. So there we go. 8 over 50. That sounds like it will reduce. 8 over 50. Hit enter on my calculator. Voila, 4 over 25. There might be some people out there that are like, I'm totally doing this in my head. Why do I need my calculator to tell me this? Cool. I'm happy that the numbers are easy and they're working out for you if that's the case. It's not the case for everybody. And also sometimes the problems get hard for everybody. So might as well know how to do a little task like reducing fractions. All right, the next one becomes 3 over 25. Again, I'm putting the number I see here over the 50. That was the sum of all those numbers. Last but not least, 11 over 50. That will not reduce because 11 is odd. And that's it. Not because 11 is odd, because it's odd and it's not divisible by 5. Okay, that's it. Nothing new and exciting. It is literally a relative frequency table, but written as fractions specifically. Oh, it does say round to 2 decimal places. Oh well, whatever. We would never have had my exciting freak out over my fraction button if I had listened to the instructions. So just follow, kind of read the problem on the homework and just follow the format that it says. Okay, next up, oopsies, move. Here, we'll do this one with decimals because look at these numbers. These numbers are humongous. I need to type all of that in. So what I'm going to do is I'm going to add all of these numbers in my calculator. Sometimes I do something like this and it's so big and I totally make like a tiny little mistake adding them up. Life goes on, right? Like it's going to happen sometimes. So if I did that, because you're not here to yell at me in person and say, well, where'd you get that number from? I think that's right. I'll double check right here. But sometimes I make mistakes on the videos and that is okay. Just shoot me an email if it ever confuses you. Okay, so there is our denominator, the 3259. Here, if I use my fraction button, if I say 941 over 3259, it's going to give me a decimal. Like it just is because that number is so big. I mean, not the number, but there's just so many big numbers involved in it. So this one is just going to be a decimal. We'll say 0.289 because I'm rounding them to 3 decimal places. 1349 divided by my denominator. So go ahead and try all these. I'm not going to talk my way through this. I'm going to pause the video. And I don't know, I tried to pause it earlier and I messed up. And then, what was I going to say? I'm going to pause. Yes, I can pause. Oh gosh, that says stop. Never mind. I'm just going to keep talking. This Zoom is driving me crazy. Okay. Pause it if you don't want to hear me talking about nonsense and then fast forward it. That's fine. So I'm just going to do all of these separately. There's not really a fast way to do this. 703 divided by 3259 is 0.216. If you are getting these slightly off, check rounding because like this one said 0.2157. So I did round up. 178 divided by 3259 is a tiny one. Don't forget that 0.055. Ooh, this one looks even smaller, 67. Oopsies. Did it slightly wrong, 3259. And I get 0.0 again. 21. It says 0.02055. So I'm going to round it up to 0.021. Last but not least, 21 divided by 3259. Very tiny, 0.006. I'm not rounding up because after the 6 was a 4. All right, those are all the answers. Again, I did this one as decimals because there really wasn't a good choice. However, we want to use fractions a lot when we can. It's not required. It's just more common. Like you're just going to see it more in problems. So you might as well practice writing your answers that way. Okay, moving on to the next topic. Properties of a probability distribution. So we just had a probability distribution, which was exactly the same as a relative frequency table. There's two rules. We've talked about the second rule before because it just happened. We didn't call it a rule. We just said it happened. And that says, the second one says the sum of all the probabilities is 1. So when you add up all those probabilities, the answer is 1. Number one, I guess because I did these backwards. The other rule is every single probability, each individual probability must be between 0 and 1. So you're going to see me reference these rules a lot here. Well, this is pretty much it before the test. There's not much more. But also after the test, we talk about these two rules a lot. So these are big rules for probability distribution. I don't even know if they're so big as like you would want to even put a flag in it by your notes, because like honestly, I'm just going to say them and you're just going to get them. Like they're not really that hard to remember. But if you do have issues remembering things, or maybe you just stress over tests and you just want to have everything lined up, I totally get it. Sure, put a flag by it. It is important. I just think you're going to remember it. Okay, number 5, we're going to use those two rules on number 5. It says determine whether or not we have a probability distribution. What am I? I'm looking at all the fun little stamps. I'm going to do a star. Okay, determine whether or not the distribution is a probability distribution. So does it follow those two rules? Select the reasons why or why not. Okay, so we have 4 reasons. There might be 1 answer. There might be 4 answers. I don't know. So first off, is it a probability distribution? Right off of the bat, the answer is no. I don't even have to try that hard. I see that that one is negative. So there's 1 reason right there. So automatically, these the bottom 2 answers are out, because see how they both say is a probability distribution. So those are already out. I know it's not. I also know it's not due to the negative. So it says, the second one says it's not a probability distribution since at least one of the probabilities is either greater than 1 or less than 0. It's the less than 0 that's the problem. So that's definitely one of the answers. I've already eliminated 2. So the only thing left to do is to determine is the top one an answer. So it says the given distribution is not, because the sum is not equal to 1. So let's add these up. 3/4 plus 1/4 is 1. Minus 1/4, well, this right here, minus 1/4 and plus 1/4 is a 0. 1 plus 0. Okay, it does equal 1. If you want to double check, just throw it in your calculator. You can see if I add it all up, including that negative in there, it actually does equal 1 because the last 2 cancel out. So I can't choose that reason. That's not the reason it failed, but it still failed because of that negative. So in order for that second one to be chosen, which is what we chose, one of those things has to be positive. It's either bigger than 1, which none of those are. They're all fractions that are less than 1, or it's negative, it's less than 0. And so to me, the negative is like the easiest one to spot because it has a negative on it. So as soon as you see that, automatic no, there's your reason. Okay, next one. We're going to make we're going to make one right here. I'm all thinking about this when I was doing it in my head earlier. I was like, oh, the table will be real easy to make, but now I am second guessing that because of the fact that I'm doing this on Zoom. Okay, we're gonna make a table. I'm gonna try to make it nice as possible. We have 2 choices. 46% say they're in favor, 48% say that they are against, and we know that it has to equal 1 whole or 100%. So we need a third category, and we're gonna call it undecided. Okay, so we have our probability distributions usually have 2 columns, the topic and then the probability. And so here I'm going to we call it X is the topic. That's just shorthand. And then probability of X, P of X is the probability. So our topics, I can't make my font smaller. So we'll just say, it says in favor. So I'm going to call them, well, I can just say in favor. I'll just move it over a little bit. In favor, against, those are the two that we can see. And then the last one, you can kind of call it whatever you want. You can call it unknown. You could say undecided. For some reason, there's this category of people that we don't know anything about. So we do know that in favor, and before I finish this, it's still a relative frequency table. Probability distribution is the same. So if you want to put 46%, do it. That's fine. If you want to put 0.46 as a decimal, that's fine. I don't care. It doesn't say on this problem. Remember, I said it's typically a fraction, but there's not an actual rule. So you can put whatever you want, whatever kind of makes sense for that problem. This problem, it makes sense to have the percentages. Okay, so the probability has to equal 1, which is the same thing as 100%. And right now I have 46 plus 48, which is I have 94%. So I'm just going to kind of narrate this over here. We have 46%, just in case you're at home and you're like, where are these numbers coming from? Which equals 94%. We need 100%. Thus, 6% are unknown or undecided. I already wrote unknown over there, so I'll put. Okay, that's what we're doing here. That's how we're going to get this bottom 6%, because we need it to add up to 100%, or we need it to add up to one whole. So we take what we know. I got that from my calculator, just adding those 2%. And then I subtracted it from one whole or 100 to find out that there was 6% left over. Okay, so again, a little different way of thinking through, but we have talked about these tables before. So the basic idea should be there. Now we're just kind of adding a little bit of layers onto it. All right, last topic. We have basic probability. Now, depending on your knowledge of statistics, you might have done really complicated statistics, or you might have just done these kind of basic things that we're talking about here. It doesn't matter. I don't want to do super complicated stuff in it. Well, let me back that up. I don't want to do super complicated probability in this class because we have so much time for super complicated stuff in the future. Today is not that day. So we are just doing basic probability in this class. If you have a friend that's taking Math 10 with a different teacher, they might spend 2-3 weeks on it. I'm spending like the last 10 minutes of this video on it. So I just want that to have the concept of probability. I don't want to talk about every scenario. It's not that important for what we're going to do. Okay. Equally likely outcomes. That's what we're going to be talking about for now. We'll talk about more involved stuff after the test when we get to chapter 4. Anyways, here we have the number of ways A can occur over the total number of outcomes. So we have a coin. Remember I was talking about flipping a coin earlier? Heads, tails are the two choices. What's the probability that I flip a heads? Well, there's two choices. One of them's heads, so 1/2 or 1/2 is the probability. All right, we're just going to work through some examples so you can see how that is. Okay, we'll worry about those other rules later. So you roll a 6-sided die one time. What is the probability that the number shown is at least a 5? So first of all, what does that mean? At least 5 means 5 or 6. Okay, let me just tell you what you should already know, because this will determine if you have extra homework this weekend. You should know what I mean when I say 6-sided die, that it's just like, that's singular for dice, and it has 6 sides on it. It has the dots, 1, 2 dots, 3 dots, all the sides. You should know some basics about a standard deck of playing cards, which is what's listed below. That means the suits, like clubs and hearts and all that stuff. You should know that there's numbers 1 through 10, and then it has face cards. If you don't know this, go to the dollar store. This is your homework this weekend. Go to the dollar store, get a deck of cards, and just play with it. Just look at all the shapes and sizes and colors of everything, because that's as much as I expect that you know. Anything else, like if I say, oh, you're playing roulette and you roll a 7, you know, or whatever. We will talk about roulette in the next after the test. I will explain what that means as we go. I don't expect you to know everything about every game in the world, but I do expect that you know what a 6-sided die is and that you know what a standard deck of playing cards is. So if you don't, dollar store. Okay, so there's 6 sides. At least a 5 means $5 or $6. So for example, how can you know this? Well, if it says, I'm gonna go to the store and I'm gonna get I don't know. I'm gonna get a coffee at Starbucks. How much do you think it's gonna cost? Oh, I think it's gonna cost at least $5. That means in your wallet, you should have $5 or more just in case. If you have $4, that's not going to cover your coffee. So if someone tells you that the coffee costs at least $5, that means it can cost $5 or it can cost more than $5. So both of those are choices. Okay, now that we know what that means, what is the probability? So I'm going to draw my fraction correctly here. There's 2 choices, 5 or 6. There's 2 choices right here that we have determined. Oh, I think I can draw an arrow here. Let's see. Oh gosh, that's the world's tiniest arrow. And it's just going to do more because it's a stamp. Okay, whatever. I'm just silly with all of these stamps today. Okay, anyways, over 6 sides total. 2 choices out of 6 sides. Number of times it could happen. So look at number of times it could happen. There's 2 things that could happen over the total number. There's 6 sides. All right, that's not my answer. That's just how I'm going to get to my answer. The final answer is going to be reduced version of that, which is 1/3. The final answer should always be reduced. Put it in your calculator. If you don't know how to reduce, not a big deal. Okay. Next up, you draw a card out of a standard deck of playing cards. What is the probability that the card will be a 6? Okay, so there are 4 suits, which are hearts, clubs. I'm just saying this for people that don't have their basic card knowledge. Diamonds and spades. Each one of those has a 6 of hearts, a 6 of clubs, and so forth. So that means we are going to have 4 different choices. There's 4, where's my, oh, I was trying to do my stamp again. There's 4 different choices here, 4 different suits. Each of them have a 6. Now, this is the one, this is your test right here. Do you have extra homework this weekend? Do you need to go to the dollar store? The question is, what number goes in the bottom? How many cards are there to choose from? If you know the answer is 52, you win. You don't need to play cards this weekend. But if you don't know that the answer is 52, go find a deck of cards and play with it so you're familiar with some of the basics of cards for probability purposes. All right, last but not least, this is not reduced. Either reduce it in your head if you know how, or put it in your calculator if you don't. Some of you, maybe you're not like super familiar with 52, but you're familiar enough with cards that you know that the answer is 1/13. Final answer. So there, we put a little box around it. 1 out of 13 is 4/52 reduced. Throw it in your calculator. All right, last but not least, I think this is the end of this. Let's scroll down. There we go. The City of London has on average 12 rainy days every March. What is the probability that it rains on a March date in London? I was actually going to delete this from these notes because I was just kind of changing things. And then I found every semester I have people that don't know how many days are in March. Okay, there's another thing you should know. How many days are in March? Okay, so this one isn't really that complicated if you know how many days are in March. It says 12 days are raining. There are 31 total days in March. That's it. Cannot be reduced. Problem solved. Got to end on a nice quick one, right? Okay, so For 3.1b, you might be called on for some basic knowledge. So go play cards or go play with the dice. If you don't know that, get a calendar. I will make another video for this, a short one. And I think that's it. So let me know if you have any questions. There will be an activity after this, but in terms of new topics, this is it for the test. Everything from 1 up till now is on the test. So I will post more information about that. Other than that, yeah, I will see you later. Bye.